Here you can see that we start out at a spreadsheet. This spreadsheet is based off of known data that's pulled from electronic health records and existing data sets. The most important field that we're going to see in this is that last column that dictates whether or not this was a patient that was readmitted or not, because we're going to try and build our model based on predicting that outcome. So here you can see we launched the tool and we source the comma-separated file that was outputted on that last page. That again was simply just a Microsoft Excel spreadsheet. This is where the tool will actually go ahead and analyze that data, do some rudimentary analysis as to what all the fields are, and then allow you to select which field you want to move forward building the model around. Right? And so we're going to find that readmitted field. So if you scroll down, you'll see each of the fields that were read from that CSV file, and at the very bottom, you'll see our readmitted value. When we click on it, we see that there are two values inside that, either true or false, and that's perfect for us to build our machine learning model around. We type in readmitted, and we'll hit the big start button. As soon as we do this, the tool actually goes through and creates all the proper partitions, holdout data sets, everything needed to do proper data analysis. And the important part is the user of this tool doesn't need to worry about that. They don't need to be a data scientist to be able to use this tool. The tool is actually doing everything under the covers. Now, once it has split and prepped the data, it will start running the algorithm competition. And this is where you can see all those threads that just spun up. Each one of those is a separate machine learning algorithm. And this is going to run this data set through each of these algorithms to find out which one works best, and then it'll stack rank them. Right? These are a combination of open source industry algorithms as well as proprietary algorithms that are built into the platform. Some of them are TensorFlow, some of them are provided by the platform, some of them are Python, R. This really comes down to letting the best, most accurate prediction results rule, rather than having a bias towards a given language or a given algorithm. You can see now they're sorted by how accurate they are, and this list will change. The more of the worker threads that you can spin up, which is dictated by your license and the hardware that you're running on, the faster that you can progress through this. Here we look at the winning algorithm, and it's actually a blended algorithm of two separate ones, and you can see how close it holds to the actual validation data. You can also see here where we can adjust and identify how many true positives or false positives would be prevalent at a given percentage. So we would throttle this to say at 80% likelihood, I only have 2 false positives, but I'm 24 true positives. That's a really good, accurate algorithm. Here, which feature is the most important or tends to make the most difference. And then here you can even see on a row-by-row basis what the reason for a given prediction is. Was it because of a patient's weight that we said they would be likely to be readmitted? All of these could dictate different courses of treatment and are very important. Here we can start throwing new data at the model, and then here we can actually deploy that model to an API and immediately begin using it from programs externally. You see it even gives us a little sample bit of Python code that we can start throwing data at as soon as possible. This allows you to put this into production faster than any other of our traditional machine learning solutions. You can see we can get some reports, whether it's the feature importance or even word cloud for unstructured fields. Which of these words contributed most towards the likelihood of a patient being readmitted or not? We can pull all of this up inside a Jupyter notebook, which would allow actual editing for folks that are familiar with programming. So it continues to deliver that capability, but it brings in a whole bunch of new people who didn't have that level of familiarity to this. Here's a list of all the baked-in native algorithms, as well as you have the ability to upload your own as your data scientists can produce them.